Hi there, welcome to Excellent Scholars Academy, and in today's tutorial we'll be looking at function of a function, which can also be referred to as chain rule. Now, so I'll be solving some questions with you so that you could get to understand how to use function of a function to find the derivative of any function. Now, this is the first question we're going to solve. Y equals 2x plus 3 to the power of 5. Now, if you look at this function very well, for you to differentiate this, you will have to open this to a power of 5. And that could take you eternity. I'm speaking metaphorically. Because that could take you to eternity. Or you could also make a mistake while doing that. So this is where function of a function or chain rule comes in. So what you do is you say, let u be equal to this function inside. So you say, let u be equal to 2x plus 3. So now you have it that your y equals u to the power of 5 because you said let this be represented by u. And then you have it that your u to be equal to 2x plus 3. Now differentiate this side and then differentiate this side. Now differentiating this now will not be dy dx. It will be dy du because you are differentiating y with respect to u. So now that will be dy du will be equal to 5u to the power of 4. That's differentiating is 5 times this, then subtract 1. Now, let's differentiate this. This will be du dx. Now, our du dx, differentiate 2x, you get 2. Then differentiate 3, constant, it's gone. Now, for us to get our dy dx, which is our main focus on this question, now, our dy dx will be equal to this function that was differentiated here, multiplied by this function that was differentiated here. Now, which will be dy du times du dx. Okay, dy du, that's what you differentiated here, multiplied by what you differentiated here. So now it will become that my dy dx is going to be equal to, your dy du is 5u to the power of 4 multiplied by 2. So 2 times 5 gives you 10. So it becomes 10u to the power of 4. Now recall that your u is equal to 2x plus 3. Recall, you have to recall because your answer cannot be like this. So finally your dy dx is going to be equal to 10 into the power of 2x plus 3 to the power of 4. And this will be your answer. I hope you understand that clearly. Now, so this is the next question we are going to be solving. Y equals square root of x squared plus 5. Now, how can you solve this? Or how can you represent this? Now, you should understand that square roots can also be written as y equals x squared plus 5 to the power of 1 over 2. Now, you can clearly see that this is a function of a function. You have this function inside another function. So now you say let u be equal to the function inside, which is x squared plus 5. So now it becomes that you have y equals u to the power of 1 over 2, and you also have u equals x squared plus 5. Now I'm going to differentiate here and differentiate here. So now differentiate here, you have dy du to be equal to 1 over 2u. Subtract 1 from this, you have minus 1 over 2. Now, which can also be written as dy du, finally, can be written as 1 over 2 root u. Okay? Because of the negativity power, this comes down, and then this is what we are going to have. Now, for this place, differentiate here. So, du dx here will be differentiate x squared, and you get 2x. Now, differentiate 5, 0, gone. Now, finally, our dy dx is going to be dy du, that's the function you differentiated here, multiplied by the function you differentiated here, times du dx. So our dy dx is going to be equal to, that will be 1 over 2 root u multiplied by 2x. Okay? 1 over 2 root u multiplied by 2x. Now, if you watch closely, these 2 can take away these 2. If you watch closely. So what will be left with will be dy dx will be equal to x over root u. Now, recall that our u equals x squared. Recall that u equals x squared plus 5. Very, very important. So finally, our dy dx is going to be equal to x over square root of x squared plus 5. And that will be our final answer. I hope you understand that. So this is the next question we are going to solve. Y equals sine 5x. Okay, now if you watch closely, this is a trigonometric function having an algebraic function inside of it. So now you say let u be equal to 5x. So you now have it now that y equals sine u, because you've represented this with 5x, and that u equals 5x. So now differentiate this side, differentiate this side. Now when you differentiate this side, you have dy du to be equal to cos u. Differentiate this side, you have du dx to be equal to 5. Now finally, our dy dx is going to be equal to dy du times du dx. Now, so that implies that our dy dx now is going to be equal to cos u multiplied by 5. So now our dy dx is going to be equal to 5 cos u. Now, recall our dy dx is equal to 5 cos u. Now recall that your u equals 5x. So finally, our dy dx, anywhere we see u, we replace it with 5x, becomes 5 cos 5x. And this will be our answer. So now this is the next question we'll be solving. Y equals exponential 2x. Now if you watch closely, if you watch this closely, this is an exponential function that has an algebraic function inside of it. So what do? We say let u be equal to that function inside of this function, which is 2x. So that implies that now we have that y is going to be equal to exponential u. And then we also have it that u is equal to 2x. So differentiate this side, differentiate this side. Now your dy, this will be dy du, because you are differentiating y with respect to u. Now if you differentiate exponential u, you still have exponential u. Now differentiate this, that will be du dx. Now if you differentiate 2x, you are still going to have 2. So now finally our dy dx, which is the main target here, will be dy du times du dx, meaning what you differentiated here times what you differentiated here. So our dy dx now will be equal to exponential u multiplied by 2. So dy dx gives us 2 exponential u. So recall that u equals 2x. So this implies that your dy dx now is going to be equal to 2 exponential 2x. And this will be our answer. Very clear, right? Okay. Now, so this is the next question we are going to solve. Y equals cosec 4x. Now, this is an algebraic function in a trigonometric function. Now, so like I said, we are going to represent this function inside with something else. So we say let u be equal to 4x. So now we'll have it that our y equals cosec u. And then we'll have it that u equals 4x. So differentiate this. Now if you differentiate cosec u, that's dy du, you are going to have minus cosec u cot u. Minus cosec u cot u. That's what you are going to have. Now differentiate this. Your du dx is going to be equal to 4. So finally, our dy dx is going to be equal to dy du times du dx. That's what you differentiated here times what you differentiated here times du dx. And if you watch closely, something I have not said so far as we've been solving this, if you watch closely, this du can cancel du. What you'll be left with is dy dx. So this principle is, this alone shows that this principle is very correct. Okay, so now our dy dx now will be equal to minus cosec u cot u multiplied by 4. So which gives us that dy dx equals minus 4 cosec u cot u. So now recall that u equals 4x. So that implies that your dy dx is going to be equal to minus 4 cosec 4x cot 4x. Okay, so this will be our answer. That will be our answer. I hope it is clear. You know, just pause the video and or rewind the video, sorry, and then watch it over again. Okay, so this is the next question we're going to solve. Simple. Y equals 1 over 3x minus 2 all to the power of 2. Okay, so now how do we differentiate this? Now you have to represent this in form of indices, because you cannot solve this like this, just like this. You have to represent this in form of indices. So I could also express this as y to be equal to 3x minus 2 all to the power of, this is 1. So it can be minus negative 2, minus 2. 3x minus 2 to the power of minus 2. So now, finally, you can now say let u be equal to 3x minus 2. So this becomes that you have that y to be equal to u to the power of minus 2, and then you have u to be equal to 3x minus 2. So differentiate this, this becomes dy du, which gives us minus 2u to the power of minus 3. Minus 3, which finally can be written as dy du to be equal to minus 2 over u to the power of 3. I hope you understand this. Differentiate this. Minus 2 times this gives us minus 2. Subtract 1 from this power gives us minus 3. So this can also be represented like this. Now, so differentiate this part. That's du dx. Now, du dx here, differentiate 3x, you get 3. Differentiate minus 2, you get 0. Okay? So now, finally, it's going to be dy du times du dx. Okay? So what do we have there? We have that our dy dx is going to be equal to, our dy du is minus 2 over u to the power of 3 multiplied by du dx, which is 3. So this times this gives us dy dx is equal to minus 6 over u to the power of 3. So now recall that your u equals from here 3x minus 2. So finally your dy dx is going to be equal to minus 6 over 3x minus 2 all to the power of 3. And this will be our final answer. I hope you understand that. So this is the next question we are going to solve. Y equals sine to the power of 3x. That means sine cube x, or sine to the power of 3. So now, how do we differentiate this? This is sine cube x. How do we differentiate that? Now, I want you to understand that it takes sine x multiplied by another sine x multiplied by another sine x to give us sine cube x. Just like if you multiply x times x times x, it gives you x to the power of 3. So it means that this can also be written as y equals sine x all to the power of 3. They are the same thing. Because as this is written like this, you can't differentiate it easily like that. You would have to represent it like this. Okay? you would have to represent this like this. So now finally you can say let u be equal to sine x, the function inside of this function. So now it becomes that y will be equal to u to the power of 3, and then u will be equal to sine x. So finally, dy du here is going to be equal to 3u squared. Du dx here will be cos x. So our dy dx is going to be dy du times du dx. Okay? So now dy dx is going to be equal to dy du is 3u squared times cos x. So this becomes that our dy dx will be equal to 3u squared cos x. Okay, so now recall that your u is equal to sine x. So this becomes dy dx will be equal to 3 sine squared x cos x. Okay, now so this is an answer. Now, although this can also be broken down, yes, this can be an answer, but this can also be further simplified. Okay, because I can also write this as, okay, or I can also write this as dy dx to be equal to 3 sine x multiplied by sine x cos x. Now, if you recall clearly, recall that 2 sine x cos x equals sine 2x. 2 sine x cos x equals sine 2x. This is a trigonometric ratio. So now, if I have this to be this, it means that sine x cos x is equal to sine 2x over 2. If you watch that closely. So meaning that I can replace this sine x cos x with this, and then this finally becomes that dy dx to be equal to 3 sine x multiplied by sine 2x over 2. So this finally becomes 3 over 2 sine x sine 2x. Now, any of this is an answer. Either this or this is an answer. So even if you wanted to differentiate y to the power of sine to the power of 2x, that's sine square x, you will still follow the same approach and then go through all this. So either this or this is an answer. Any form in which you want to leave your answer or in which you find your answer if you are to write an objective exam. I hope you understand what I mean. So now this is the next question we're about to solve. Y equals 2 to the power of sine 2x. Now, looking at this, how can we differentiate this? So now, this is a function in another function. So you can say let u be equal to sine 2x. Okay, let u be equal to sine 2x. And so now we're going to have it that y will be equal to 2 to the power of u, and then u to be equal to sine 2x. So now we'll differentiate this side and differentiate this side. Now, if you differentiate a constant to a variable, which is like something like this, 2 to the power of u, that will be dy du will be equal to, is going to be equal to 2 to the power of u, then ln 2. 2 to the power of u, then ln 2. Now we're going to differentiate this. Now this can be differentiated by the same chain rule we are into. But because of our time, I'm going to differentiate it. So differentiating this, one of the tricks to differentiating a chain rule is differentiate the inside function. So differentiate 2x, you get 2. Now differentiate sine, you get cos. then with the 2x. So this was actually can also actually be differentiated by chain rule or function of a function. But though I did not show that, but you could go through that and see you get this. So now finally our dy dx is going to be equal to dy du times du dx. So our dy dx is going to be equal to 2 to the power of u ln 2 multiplied by 2 cos 2x. Okay, so now recall that your u is equal to sine 2x. So what's going to happen here? So it becomes 2 to the power of sine 2x ln 2 multiplied by 2 cos 2x. Now, according to the law of indices, this is 2 and this is 2. This has an invisible power of 1. So we can bring them together by multiplication law of indices. That this now finally becomes 2 to the power of sine 2x plus 1 then ln 2 cos 2x. And this is going to be our answer. That's going to be our final answer. This and this came together as there's an invisible power of 1. Don't forget law of indices. If you have a to the power of x times a to the power of y, it becomes a to the power of x plus y. So that is what happened here. And that's why this became this. And then that's our final answer. Okay, so this is the next question we're going to solve. Y equals ln 2x to the power of 3. Now, you say let u be equal to 2x to the power of 3. So now we have it that y equals ln u, and then we have it that u equals 2x to the power of 3. Now differentiate this side. You have your dy du to be 1 over u. Differentiate this side. You have your du dx to be equal to 3 times, that's 6x squared. So now your dy dx is going to be equal to dy du times du dx. So this becomes that dy dx is going to be equal to 1 over u multiplied by 6x squared. So now finally our dy dx is going to be equal to 6x squared over u. Now recall that your u equals 2x to the power of 3. So that means dy dx is going to be equal to 6x squared over 2x to the power of 3. Now 2 go in 6, that's 3. Now this x to the power of 2 and x to the power of 3. X to the power of 2 takes away x to the power of 2 here. We're going to be left with x to the power of 1 here. So this finally is going to be that dy dx will be 3 over x. And this will be our final answer. Okay, so this is the next question we're going to solve. Y equals ln sine x. Now, you say let u be equal to sine x. Okay, so now you have it that y to be equal to ln u, and then you have it that u to be equal to sine x. Now differentiate this, that's dy du is going to be equal to 1 over u. Now differentiate this, that's du dx is going to be equal to cos x. So now your dy dx is going to be equal to dy du times du dx. So our dy dx is going to be equal to 1 over u multiplied by cos x. So this becomes that dy dx is going to be equal to, this becomes cos x over u. Now recall that your u equals sine x. So dy dx is going to be equal to cos x over sine x. Now, if you check this out very well, this is also a trigonometric identity. Now, sine x over cos x gives us tan x. So it means cos x over sine x now with the inverse of tan, which will be cot. So recall that cos x over sine x equals cot x. So that means our dy dx will be equal to cot x. And this will be our final answer. So now this is the next question we're going to solve. Y equals tan 4x plus 1. So now you say let u equals 4x plus 1. So we have it that y is going to be equal to tan u, and then we have it that u is going to be equal to 4x plus 1. So now differentiate this becomes dy du to be equal to sec square u, and then we have that du dx is going to be equal to 4. When you differentiate 4x, you have 4. When you differentiate 1, gone. Now dy dx is going to be equal to dy du times du dx. Now, so dy dx is going to be equal to sec square u times 4. So dy dx is going to be equal to 4 sec square u. So now recall that u is going to be equal to 4x plus 1. So finally our dy dx is going to be equal to 4 sec square 4x plus 1. And that will be our answer. Now this is the next question we're about to solve. Y equals square root of x squared plus 6x plus 3. Now, I advise you to pause this video and try differentiating this to see if you are going to get the same answer as what I'll get when I'm done solving this, or when we are done solving it, since we're solving it together. Remember, this is not just me solving it, this is me partnering with you to solve this, okay? So now, you say let u be equal to x squared plus 6x plus 3. So now we're going to have it that y is going to be equal to square root of u, which can also be written as u to the power of 1 over 2. Now also we're going to have it that u equals x squared plus 6x plus 3. Now differentiate this, you have dy du to be equal to 1 over 2u to the power of minus 1 over 2. Now here your dy du finally can be written as 1 over 2 root u. Okay, so now differentiate this, which will be du dx is going to be equal to, differentiate this, you have 2x, differentiate this, you have 6. Okay, so finally our dy dx will be dy du times du dx. So finally our dy dx will be equal to 1 over 2 root u multiplied by 2x plus 6. Now, if you watch 2x plus 6 closely, 2 is common between 2x and 6. Now, so it's going to become that dy dx will be equal to 1 over 2 root u times 2 into the bracket x plus 3. Now, if you watch closely, 2 is going to take away 2 here. Okay? 2 is going to take away 2 there. So you have it that dy dx will be equal to x plus 3 over root u. Now, recall that your u is equal to x squared plus 6x plus 3. So now dy dx is going to be equal to x plus 3 over square root of x squared plus 6x plus 3. And this will be our final answer. Now, I hope this was the answer you got while you pause the video and try solving it. So that will be our answer for that question. Okay, so now this is the next question we're about to solve. Y equals arc sine tan theta. Arc sine tan theta, meaning the tan theta is inside the function of arc sine. Do you understand? So now tan theta is a function inside the arc sine function. So we're going to say let u be equal to tan theta. Now this y now is with respect to theta. So we're not looking for dy dx in this case. We're looking for dy d theta. So now this becomes that you have y to be equal to arc sine u, and then you have u to be equal to tan theta. So here we have dy du to be equal to, when you differentiate arc sine, you are going to get 1 over square root of 1 minus x squared. Okay, now differentiate this part, which will be du d theta, because you are differentiating u with respect to theta. This becomes sec square theta. Okay, so now our dy dx now, okay, sorry, This u, this is with respect to u now, so this will not be x now. This is going to be u squared. Okay, this is going to be u squared because you are differentiating y with respect to u. So this is going to be u squared, not x squared. Now, so our dy dx now will be equal to 1 over square root of 1 minus u squared, which is saying dy du times du dx times sec square theta. So now multiply this, we are going to have it that dy dx will be equal to sec square theta over, recall u is equal to tan theta, 1 minus u squared. Dy d theta will be equal to sec square theta over square root of 1 minus, now when you square the u, which is tan, it becomes tan squared theta. Okay, I hope you understand that. Now this can be our final answer. Okay, so this is the next question we're going to solve. Y equals exponential minus 2mx. Now, so you say let u be equal to minus 2mx. So now this becomes y equals exponential u, and then u equals minus 2mx. Now differentiate this, this will be dy du, which is going to be equal to exponential u. Differentiate this, this will be du dx, which is going to be equal to minus 2m. Now, dy dx is going to be equal to dy du times du dx. So now our dy dx is going to be equal to, our dy du is exponential u multiplied by minus 2m. So this becomes that dy dx equals minus 2m exponential u. Now recall that your u equals minus 2mx. So your dy dx here is going to be equal to minus 2m exponential minus 2mx. And this is going to be your answer. Okay, so this is the next question we are going to solve. Y equals 2 cot 5t squared plus 3. Now you say let u be equal to 5t to the power of 2 plus 3. So now this becomes that y equals 2 cot u, and then you have u equals 5t squared plus 3. Now, so dy du here is going to be equal to 2. Now, if you differentiate cot u, you are going to have minus cosec square u. So this becomes minus 2 cosec square u. Okay, so now differentiate this, that will be du dx. This becomes, differentiate 5t squared, you are going to get 10t, and differentiate 3, constant, gone. So now our dy dx now is going to be equal to dy du times du dx. So our dy dx now is going to be equal to minus 2 cosec square u multiplied by 10t. Now, which becomes that dy dx will be equal to, now this time this, that gives us minus 20t cosec square u. So recall that u equals 5t squared plus 3. So this becomes that our dy dx, which is our final answer, is going to be minus 20t cosec square 5t squared plus 3. And that will be our final answer. I hope that is clear. Now, so this is the next question we're going to solve. Y equals sine into 2x to the power of 3 plus 3x minus 4. Now, you say let u be equal to, this is a polynomial function inside a trigonometric function. So you say let u be equal to this. So it becomes 2x to the power of 3 plus 3x minus 4. So now this becomes that you have y to be equal to sine u, and then you have u to be equal to 2x to the power of 3 plus 3x minus 4. Now differentiate this part, you have dy du. Now if you differentiate this, you have cos u. Now differentiate this part, you have du dx, which is going to be 3 times this. That gives us 6x squared. Differentiate this, that gives us 3. Differentiate this, gone, 0. Now our dy dx is going to be equal to dy du times du dx. Dy du times du dx. Now, so dy dx will be equal to, our dy du is equal to cos u. So that becomes cos u multiplied by 6x squared plus 3. So dy dx will be equal to 6x squared plus 3 multiplied by cos u. So now recall that your u equals 2x to the power of 3 plus 3x minus 4. Okay, so finally our dy dx is going to be equal to 6x squared plus 3 cos into bracket 2x to the power of 3 plus 3x minus 4. So this is going to be our dy dx. Okay, so this is the next question we're going to solve. This is cos x squared. So now this is a polynomial function inside a trigonometric function. Okay, so now you say let u be equal to x squared. So this becomes that y equals to cos u and then u equals to x squared. So differentiate this part. Now if you differentiate cos u, you are going to have minus sin u. If you differentiate this, that's going to be du dx. You are going to have 2x. So our dy dx is going to be equal to dy du times du dx. So now dy dx is going to be equal to minus sin u multiplied by 2x. So this becomes that dy dx will be equal to minus 2x sin u. Now recall that u will be equal to x squared, or u is equal to x squared. So dy dx finally is going to be minus 2x sine x squared. That will be your final answer. Okay, so this is the next question we're going to solve. Y equals log 2x minus 1 to base 10. Now, so you say let u be equal to 2x minus 1. So now you have it that y equals log u to the power, okay, log u to base 10, sorry. Then you have u to be equal to 2x minus 1. Now, if you differentiate this, that will be dy du is going to be equal to 1 over, okay, so if you differentiate a logarithmic function like this, what are you going to have? That becomes 1 over u ln 10. 1 over u ln 10. Okay, so now differentiate this part, that will be du dx becomes, differentiate 2x, you have to differentiate 1, it's gone. Now finally our dy dx will be equal to dy du times du dx. So this becomes that dy dx is going to be equal to 1 over u ln 10 multiplied by 2. So this becomes that dy dx will be equal to 2 over u ln 10. So recall that your u equals 2x minus 1. So this becomes that you have dy dx will be equal to 2 over 2x minus 1 ln 10. So that will be our answer. Okay, so this is the next question we're going to solve. Y equals r cos 4x squared. Now, you say let u be equal to 4x squared, because 4x squared is a function inside the function of arc cos. So now you have it that y will be equal to arc cos u, and then you have it that u is equal to 4x squared. Now differentiate this part, differentiate this part. Now differentiate this part. You have dy du to be equal to, now if you differentiate arc cos u, you are going to have 1 minus 1 over square root of 1, because this is with respect to u now, because 1 minus u squared, but negative 1 over square root of 1 minus u squared. Now if you differentiate this part, this will be du dx. This is going to be 8x. Okay, now so my dy dx finally is going to be dy du times du dx. So it's going to be dy dx will be equal to minus 1 over square root of 1 minus u squared multiplied by 8x. So this becomes that dy dx will be equal to minus 8x over square root of 1 minus u squared. Now recall that u equals 4x squared. Okay, so now finally our dy dx will be equal to, when you substitute this here into this u squared, it becomes minus 8x over square root of, substitute this 4x squared into this, that's square it. This becomes 1 minus square this, it becomes 16x to the power of 4. Okay, 16x to the power of 4. So our final answer is going to be minus 8x over square root of 1 minus 16x to the power of 4. So that will be our answer. So this is the next question we're going to solve. Y equals to exponential t cos t. Now this is a function inside an exponential function, t cos t. So you are going to say let u be equal to t cos t. So this becomes that you have y to be equal to exponential u, and then u to be equal to t cos t. Now differentiate this part. You have dy du to be equal to exponential u, and then you have it that, now if you look at this function, this is t cos t. They are two products of each other. So the only way I can differentiate this is by using product rule. Now make sure you do well to watch my video on product rule. Okay, so now this will be du dt now will be equal to, now how do we do product rule? You take one of it multiplied by, you differentiate the other, that means minus sine t, plus, now you take this other, you take this other one which is cos t, multiplied by differentiating the other one which is 1. So our du dt here, but that's by using product rule, gives us minus t sine t plus cos t. So our du dt will be minus t sine t plus cos t. So now finally our dy dx, now this is not going to be dy dx in this case. This is going to be dy dt, because we are differentiating a function of y with respect to t. Okay, so always be careful. You know, as calculus students, sometimes dy dx could master us so much and then we make some mistakes. But this will be dy dt, because this is y with respect to t. I hope you understand that. So this will be our dy dt now is going to be equal to dy du times du dt. So our dy dt will be equal to exponential u multiplied by minus t sine t plus cos t. Okay, so now this becomes, I could write this as dy dt to be equal to minus t sine t plus cos t, all multiplied by exponential u. So now recall that u equals, if you check again, t cos t. So now this is going to be equal to that dy dt will be equal to minus t sine t plus cos t, all to the power of exponential t cos t. And this will be our final answer. minus t sine t plus cos t multiplied by exponential t cos t. And that'll be our final answer. Now make sure you like this video, subscribe and share. Give a thumbs up to this video so this video could reach other students having issues with this topic. Thank you.